My name is John Constantinidi. I'm chairing this seminar entitled Energy Management, a Crucial Component of Operations and Maintenance, sponsored by TC 7.3, Operations and Maintenance Management, which meets at 1:00 p.m. this Tuesday. Our first speaker is Mr. Terrence Rollins. Over the past 30 years, Mr. Rollins has been actively engaged in the Energy and Facility Management Professional Development category, which resulted in a total of 6 awards, including 2 Energy Star Awards for Department of Defense and Government Service Administration sites. He works as a project manager with RHC Global Energy Solutions. Mr. Rollins was an Association of Energy Engineers presenter speaker and a moderator at the 2014 World Energy Engineering Congress. Due to his outstanding accomplishments in training and the development of energy engineers and managers, Mr. Rollins was presented the Association's Energy Professional Development of the Year Award for Region 1 in 2013. He's the author of the RHC Global Energy Solution Master's Thesis. Mr. Rollins.
Thank you, Mr. Chair. Really appreciate that introduction. I actually didn't know I was the person who was that was written about. I thought it was someone else. Good afternoon, everyone. How's everyone doing today? Great day to be in the industry. Great day to be part of ASHRAE, Year Our Lord 2017. The specific presentation for our committee is written as Operations and Maintenance Management Plan Annual Program and the Impact on Energy Conservation. Our learning objectives for this presentation is to examine an example OMMP plan, annual program, an example Microsoft Project CMMS implementation plan. Objective number 2, understand how to incorporate condition-based monitoring using the CMMS platform and the building automation system. The building model can be more productive by reducing energy and reducing energy cost. Objective number 3, we evaluate the technology and the strategies to track annual maintenance, cost, and energy savings. Objective 4, implement the ASHRAE Operations and Maintenance Management perspective by writing, listening, and communicating the energy model and management reports. Acknowledgements. I would like to thank ASHRAE, Mr. Constantine, the chair, Robin Ellis, Mitchell Swan, Richard Shaw, and Frederick McKinley Jones. Our outline today is as such. We're going to do a brief review of the Integrated Design Product Team, the ASHRAE Energy Design Standards and the Successful O&M Strategies, Sustainable Facility Operations and High-Performance Green Buildings, ASHRAE Energy Design and Lean Six Sigma, OMMP Strategies and Solutions, and the OMMP Annual Program and the Impact on Energy Conservation. Our traditional design team, as we probably knew, that the customer worked directly with the architect, and they brought on the team to administer the programs for their new buildings and or projects. The traditional design team, they considered new and different methodologies in building design and the use of project as an innovative incubator. They established open communications with early input in project strategies from all parties. They conduct the owner's project requirements workshops, and project kickoff meetings to discuss the goals and to facilitate mutual cooperation, provide life cycle costing to determine the feasibility of project systems, taking into account future organization and staffing levels expected once the facility is built. The integrated design project team has a new strategy or paradigm shift. It integrates the design to a method of design and construction that uses an interactive team approach for all phases of the project management. It also addresses the integrated design of some forms of necessary to achieve the 30 to 50% energy savings over the minimum code requirements of ASHRAE NCA standards 90.1, 2004, and also an integrated design. All parties work together, so that means everyone has to partner, no change orders, all right, no gotchas. I mean, we have to work together, put our cards on the table for a common goal, okay? All right, then we need an integrated design. We'll look at the construction. We'll maximize the efficiency of the project to yield the coordinated, constructability, interoperability, and then the cost-effective results. This approach increases productivity. It provides a higher performing building and protects construction costs and reduces unnecessary change orders. We know we don't like change orders, right? I see a gentleman in the background smile, raise his hand in the back there. Okay, let's look at our typical model that we have here. We look over to the left, the traditional project design team as illustrated earlier. We know your role. What's your role? Are you the owner? Are you the architect? What's your role? Are you the contractor? And life cycle team, sports. Let's look at the integrated project design team. It sees that everyone is involved in a process. Everyone gets a chance to have their input, their involvement. Who worked on the integrated process as such? I've seen a bunch of hands raised up. That's okay. I know that you've all been, down through your 50, 60 years of experience, know what it takes to work in a team and also to help. Why? Once that building has given birth to a new owner, we have to maintain it to the design intent. So we need to have everyone's involvement, everyone's buy-in. Put your cards on the table. Do you want this chiller or do you want this boiler? What do you like? What's your standards? Okay? All right. The integrated design product team, the team is usually identifies a certain number of optimum energy conservations. I believe in a specific chapter of the Energy Design Guide, Chapter 5. Let's look at in this example, the HVAC equipment. So we know that most HVAC systems are energy consuming equipment. We're always looking to improve the operations in the building. Through life cycle cost analysis, we need a more complete energy model and initial cost for our energy conservation methods. Things are changing, technology is changing, equipment is more efficient, and this is able to be sustained over the life of a project. Okay, we also need to look at the matrix of options and to develop and assess each ECM. Is there financing, internal financing, external financing? We need to look at all of our opportunities. We always look at, as you know, the first cost for the investment. And we also look at the anticipated annual cost savings and the operating cost savings. Okay? And then we look at the anticipated maintenance and operating savings costs. Does that make sense, everyone? Is that clear? Outstanding. Additionally, we always look at a simple payback. One of my bosses used to say, well, do life cycle cost equipment, it's just on equipment only if it's an energy consuming piece of equipment. I said, well, the construction cost and the O&M, the additional cost is going to cost more. Put it in there and let's see if we buy down and we can get it funded. So we also need to look at the return on investment of one of our benchmarks, 1,000 BTUs per square foot per year reduction. It's also recommended that we'll also commissioning. Commissioning has to be further on. You'll see this twice. Commissioning is very important. On an annual basis, a brand new facility, we also want to prove the energy model. So it's very important to see what our train trace analysis and our computer analysis is doing and our energy model and our selection of equipment. We need to make sure that we commission those pieces of equipment to maintain the energy model. We need to also understand the carbon emission savings when you're looking at reducing costs of different type of pieces of equipment, if you're looking at the types of boiler technologies that are out there. Okay, we also are looking at additional percentage savings as compared to applicable ASHRAE IAS standards 90.1. We also need to understand the potential United States Green Building lead points that we use for energy and atmosphere to get those particular credits. Sustainable facility operations. The owners, or chain of command, we need to develop relationships with our owner. We need to understand what their corporate strategy is. We need high performance, sustainability. We need to stay in our facilities. We have these brand new facilities. We need to understand what type of adjustments and requests and expenditure approvals is required to take us to that level. Okay? Funding is designed to achieve a specific goal. Energy funding, O&M funding, construction dollars, capital equipment requests. We have different buckets in which how we fund our particular projects, and also contains on projects contributions, okay? And maybe even donors, such as ASHRAE, right? Grants. He's shaking his head, isn't that right? Yes, sir. Okay. We need to identify and establish the integrated product team to develop and implement practices regarding building level sustainable maintenance and operations. It's very important that we understand your customers' business goals and their strategies, because they want to focus on their core business. ASHRAE Energy Design Standards and Successful O&M Strategies. It is recommended, once again, that we require commissioning and further augmented the process. I believe in the ASHRAE Energy Design Guide for smaller office buildings, to suggest and or recommend that commissioning a matrix in C1, that we follow that guide by the book to ensure, to see that we're following the standards that is set forth in the design guides. We understand that we have owner and municipality agency and property management firms that require energy benchmarking for their tenants and newer tenants. They want to attract new people into that beautiful building. So we will make sure they have all the bells and whistles that will make it attractive to attract customers. That's what it's about, bringing customers into these outstanding buildings. We also need to include the following information, which will require a green building rating system of your choice, your team, your philosophy, what zone that you're in, what part of the country. You all have those systems are related to your design engineering standards. Okay, we also need to look at the best practices and projects to communicate emerging technologies. In this type of environment, you may want to consult with a daylighting expert, because if you have the core and shell and the roof and the windows, everything is tight. You have smaller heating and cooling systems, doesn't require much energy. You want to take a look at that. The tighter the envelope, the better the envelope, the smaller the system, lower the energy cost. So you want to look at those investments as well from a operations standpoint. Okay, ASHRAE Energy Design Guide and the Lean Six Sigma OMMP strategies and solutions. I figure instead of saying operations and maintenance plan, I would just say OMMP for some of you that are out there, gamers today that are out there having fun. So OMMP, these strategies, in this process, we're going to identify the level of maintenance training of the facility management team. Okay? We want to look at, do we have the $500,000 maintenance cost, $600,000 maintenance cost building, $800,000 maintenance cost building? We understand that. We want to look at the constraints. We want to understand the pre-existing standards that we have out there that you are designing to. You also want to look at the corporate sustainability policies, the site-based measurements. M&V is very important, one expert said to me today, that what if you had a wish list, what would you like to do after your design? M&V and commissioning, M&V and commissioning, okay? We need to understand and know the design energy model. Voila. We need to look at our fishbone effect of cause and effect, that when you see the blank line there that says blank, that's your design philosophy. That's what you believe in as an engineering firm in engineering, what your customers are looking for. That is designed based on your input and what you want. These particular things are deal points, such as our project managers, our asset management team. We want to get everyone involved in this process because we want to develop an OMMP plan that overlaps with the commissioning plan. Oftentimes, owners do not always know the type of CMMS system that they want, so we have to help them make that decision. So today we examine an example OMMP annual program and MS project plan I'll show you here shortly. We need to publish it. We need to look at condition-based monitoring. We need to understand the building automation system. As I used to say to an expert, Ms. Swan, said, Mr. Rollins, if you had your ideal piece of equipment and building, what would you want? I want four-wheel drive up front. I want my BIM model. I want it to communicate with my BAS system, and I want to export the information to my CMMS system. So if I have energy consuming data points that can trigger alarms that's not performing to what it needs to be, I want to create a work order for our team to go out and look at the potential opportunity for improvement. Okay? We need those technologies. So of course we need EM&V. It's desired. Okay? This is an example of a project plan. I'll have some here for the side that anyone want to take a look at of things we worked on in industry, working with Mr. Swan. We've developed some works in the industry to look at what we need to do to overlap the construction management program and the commission all the way to operations and maintenance. Okay? Some of the action, the deal points is an example of a maximal implementation. I just found out last week, Tri-Riga has opportunities that can interrelate, interoperable with the BAS systems and export some of the systems to cloud. Project Tech can do that with some of the Maximo systems out there, technologies out there. You can find that out there on the web. Right, okay. Virtual facility tour. Here's one particular building that was an advance that Mr. Swan was involved in years ago. The building on the left, and you see this has the roof, the windows, everything that you need to have a smaller footprint of the type of equipment that you want. Here's the existing institutional building, government-grade building to the right that updated some of its systems later on as it was built. There's another system that was developed here on the left, institutional government system, that it was put together in pods with a thermal storage system. And of course, our old tried and true Thomas Jefferson building, where we did energy audits in 2008, and in 2014, they implemented energy conservation measure. We know we have to look at that core and shell. It's really difficult. You have to get with the architect of the Capitol and look at match things that you do with that facility. It's a precious facility. Here's one of our babies that we talked about before with our BIM model and our statistical awareness and the actual overcladding of that particular building to meet those standards in the virtual tour. You know, when you're in the field, I go from the suit to the safety shoes and a hard hat, and I get in the field. I start commissioning. And at this point, I would like to ask, that concludes this particular briefing, and I would like to open up the floor if there are any questions at this time.
Thank you very much. Let's give him a round of applause for presenting. Any questions from the audience?
Thank you, Terrence. This is Carl Schultz with AECOM. I design buildings. I was wondering if you could blow my mind with an example of something that might surprise a designer of HVAC systems that you've seen in O&M experience.
When, so can you hear me? Everyone hear me? Great question. Once you're doing design, what is the opportunity improvement? Sometimes organizations will look at the type of CMMS system that they have and may not be robust enough for the assets that you have. They don't always look at the PM task that's required to maintain the piece of equipment that you design. They may or may not have the staff or the skill set to maintain the design the way you designed it in your energy model. You go back a year later and you say, hey, what happened? We didn't meet the energy model. What happened? Well, the building's consuming energy now that you've left. Well, write in the contract to see if you can. We'll come back 3 months, measurement verification. We'll give you all your utility bills. Import those into an Excel spreadsheet so we can upload them into our model so we can track the trends against what we have designed and what's actually happening in the field. That happens often. So if you can put in your services, we'll have one of our experts come and get some data for us. If you put MNV in there and then your utility bills, we want to track it against design because weather normalization changed. So we want to see where we're at. So a year later, you got that rebate check, right? They gave you a rebate check. So you want to maintain that energy profile. It's not supposed to do this. Unless the weather changes, you want to do this over a period of time. Sometimes skill sets such as a facility management team may be existing. They don't have the training to understand these high-tech buildings. That's why the Federal Building Act requires that folks get trained in the government, outside the government, private industry, to ensure that you understand the type of building that you're managing and maintaining. You cannot re-engineer a brand new building after it's been installed, right? You have to believe in the design. You have to believe in the designer's design. You have to commit yourself as a facility management professional, energy professional. I need to know your design. I need to understand it. I'm sold on it. Then I can sell it downstream to our staff, things that need to be done to maintain that design. And then once you come back a year later and say, our design met the expectations, do you have any referrals? Any more questions? Thank you.